All right, so somebody asked me about question 2 from the exercise set 4F, where we're talking about a particle moving. So the particle's moving in a straight line, and its position after t seconds is 8 plus 2t squared. And then we're moving from point A and point B. So we're saying point A is where t equals A, and point B is where t equals A plus h. It wants us to find the average velocity as it moves from A to B, and then the instantaneous velocity as it passes through A. So the average velocity is going to be P of A plus H minus P of A divided by A plus H minus A. I'm just doing the rise over run idea. It's a secant line because it's an average that's connecting two separate dots. And so that would be using the definition of our function, 8 plus 2 times A plus H minus 8 plus 2 times A squared. I think I forgot to say squared on the first part. And then A plus H minus A becomes H. You can distribute out the first chunk to be 8 plus 2, and then we're going to have A squared plus 2AH plus H squared. So I distributed the 2. While I said that, I just said A squared plus 2AH plus H squared, and then multiplied each of those by 2 because of this guy right there, and then distribute the negative. And so then the average becomes 8 cancels 8, 2a squared cancels 2a squared. H's are going to cancel out nicely as well. So I have 4ah plus 2h squared over h. So the average rate of change is 4a plus 2h. All right. Yeah, cancel the H's. And so what this is saying is that your average speed is 4 times the time value, because A was the time value, plus 2 times the distance that you move away. So for example, if you were at t equals 5 seconds and you want to know the speed between 5 seconds and 7 seconds, then you would do 4 times 5 plus 2 times 2. And the reason I said 2 instead of 7 is because I chose a number that was 2 seconds past 5, and h represents the time past it. Although I suppose h could also be a negative number, so you could look at the speed as you go from like 5 backwards to 3, and you just have a negative value. Okay, regardless, that's part A. Part B asks for the instantaneous rate of change, and that means that h is equal to 0. We're not looking anymore at a gap. We're looking at an instantaneous moment. And so we just have 4a, which you will recognize as just being the derivative of the above function with a plugged in because it asked about the point A. All right, so that's it for that. Please comment or ask me in any other way for questions.